In section 7.5, we're looking at radical equations. So when solving radical equations, we want to raise each side of an equation to a power. If y is equal to x, then y to the n is equal to x to the n for all natural numbers n. So what we want to do is we are going to isolate the radical by itself on one side, and then to undo the radical, we're going to raise it to the power that is the same as its index. So if it's a square root, we're going to square both sides. If it's a cube root, we cube both sides. So starting with example number 1, we have the square root of 10x plus 5 minus 1 equals 2x. The first thing that we need to do is we are going to add 1 to both sides so that we can isolate the radical by itself on the left-hand side. So our negative 1 and 1 cancels, and we have that the square root of 10x plus 5 is equal to 2x plus 1. Now to undo the radical, we are going to square both sides. And so on the left-hand side, the square root and the square cancel, and we're just left with the piece that is underneath the radical. So just 10x plus 5. On the right-hand side, we're going to want to write this twice and FOIL it. So we have 10x plus 5 equals 4x squared plus 2x plus 2x plus 1. And so the radical's gone, and we have a quadratic on our hands, and so we just want to solve this as we've done previously. On the right-hand side, we have a 2x and a 2x that we can add together. So we have a plus 4x in the middle. And since this is a quadratic, we want to set this equal to 0. So I am going to subtract 10x, and I'm going to subtract 5. And so our left-hand side completely cancels, and we have 0 equals, we have 4x squared minus 6x minus 4. Now from here, we want to see if we have a GCF so that we can factor this a little bit easier. There is a GCF, and we have a GCF of 2. And what I have left over is 2x squared minus 3x minus 2. And so let's go ahead and factor the right-hand side. This is going to factor as 2x plus 1 and x minus 2. And we're going to set each piece equal to 0. We have 2x plus 1 equals 0, and we have x minus 2 equals 0. We don't care about the 2 being equal to 0 because it doesn't have a variable. And so let's go ahead and solve. We're going to subtract 1 from both sides. And we get that 2x equals negative 1, and then dividing both sides by 2, we get that x equals negative 1/2. Let's go ahead and look at the other equation. We're going to add 2 to both sides. And so we end up with x is equal to 2. So we have 2 solutions. We have -1/2 and 2. You always want to make sure that you check your answer to make sure that it makes sense in the original equation. And if you check both of these, they both end up working perfectly. So -1/2 and 2 are the solutions to our equation. Let's go ahead and try another one. We have the square root of 5x plus 1 minus the square root of 3x is equal to 1. So the first thing we want to do is we want to isolate one of these radicals. It doesn't matter which one it is as long as one of them is isolated. So I'm going to just add the square root of 3x to both sides. So we have the square root of 5x plus 1 equals 1 plus the square root of 3x. So to undo our square root on the left-hand side, we are going to square both sides. And so on the left, the square and the square root cancel, and we're just left with 5x plus 1. And on the right, we want to write this twice so that we can FOIL it. So on the right-hand side, we have 1 plus the square root of 3x plus the square root of 3x plus the square root of 9x squared. And so we can actually go ahead and simplify the square root of 9x squared because it's a perfect square. And we have like terms in the middle. So we have 5x plus 1 equals 1 plus 2 times the square root of 3x. And the last term is going to simplify as just 3x. And so the problem is I still have a radical that's inside my equation, so I need to repeat the process again. I need to isolate the square root of 3x first, and then I can square both sides to get my final answer. So I am going to get the square root of 3x by itself. I'm going to subtract 1 from both sides, and I'm going to subtract 3x from both sides. And so what I end up getting is 2x, and then our 1's cancel, is equal to 2 times the square root of 3x. And so I'm just going to isolate it just a little bit more. I'm going to divide both sides by 2 so that the square root is completely by itself. But the 2 is going to cancel on both sides. And I end up with x is equal to the square root of 3x. And so to get rid of the square root, we are going to square both sides. And so on the left I have x squared, and on the right I'm just left with 3x. And so because this is quadratic, we want to set it equal to 0. I am going to subtract 3x from both sides. And so we have x squared minus 3x equals 0. And so now we look for a GCF, and we have a GCF of x, and I'm left with x minus 3 equals 0. And so we go ahead and set each piece equal to 0. We have x equals 0, and we have x minus 3 equals 0. The first one's already done, but the second one we're just going to add 3 to both sides. And so I end up with x is equal to 0 and x is equal to 3. And again, you always want to just double check your answers in the original equation to make sure that they actually make sense. And both of these do. And let's go ahead and try a little bit of a doozy. We have the square root of 2y plus 5 minus the square root of y minus 1 equals the square root of y plus 2. So again, I have to have only one radical isolated so that I can square both sides and start simplifying. Well, the square root of y plus 2 is already isolated, and so what's going to end up happening is we're just going to square both sides to begin with. We have the square root of 2y plus 5 minus the square root of y minus 1. And that whole thing is getting squared, and that's equal to the square root of y plus 2 squared. And so on the right, it's going to cancel, but on the left, we're just going to write this twice so that we can FOIL it properly. And that's equal to y plus 2 on the right-hand side. So let's go ahead and FOIL the left-hand side. Now this looks like a doozy, but if you haven't noticed so far, if I multiply two square roots with the same radicand, what ends up happening is we just get the radicand to begin with. So the square root of 2y plus 5 times the square root of 2y plus 5 is just going to give me 2y plus 5. Then for our outside, I am just going to leave this as multiplied or factored form. We have 2y plus 5 times y minus 1, and then we get the same thing again. And the same idea is going to happen with the last term. We're going to end up with just a y minus 1. Now be careful of the signs, because I have two negative radicals, it turns into a positive y minus 1. And this is still equal to y plus 2. So let's go ahead and combine like terms so that this is a little bit easier to look at. The two middle terms are the exact same thing, and they both have a coefficient of -1. We have a y and a 2y, and we also have a 5 and a -1. So we end up getting 3y plus 4 minus 2 times the square root of this long radical 2y plus 5 times y minus 1, and this is equal to y plus 2. Now again, the problem comes up because I still have a radical involved. So we want to isolate the radical as much as possible. So I'm going to subtract 3y, and I'm going to subtract 4 from both sides. And so it cancels on the left. And we have negative 2 times the square root of 2y plus 5 times y minus 1 equals negative 2y minus 2. And so actually on the right hand side, we can factor out a GCF. We can factor out a negative 2, and I'm left with y plus 1. Well, we're going to isolate the radical just a little bit more. We're going to divide both sides by negative 2. And so what ends up happening on both the left and right is that the negative 2's are going to cancel. And so we end up getting the square root of 2y plus 5 times y minus 1 is equal to y plus 1. And so we need to get rid of the radical, and we are going to square both sides again. So the left-hand side, the square and the square root cancel, and we're just left with the inside portion, so just the 2y plus 5 times y minus 1. And then I'm going to write out the y plus 1 twice so that we can FOIL it. And so we're going to end up FOILing both the left and the right hand side. So on the left hand side we get 2y squared minus 2y plus 5y minus 5. And on the right we get y squared plus y and plus 1. And so we can combine like terms. So we have 2y squared plus 3y minus 5 equals y squared plus 2y plus 1. And so again we have quadratics, so the goal is to set this equal to 0. So I'm going to subtract y squared from both sides. I'm going to subtract 2y from both sides, and I'm going to subtract 1 from both sides. And so the right hand side, everything is going to cancel, and we end up getting y squared plus y minus 6 equals 0. And so we want to go ahead and factor this. This is going to factor as y plus 3 times y minus 2 equals 0. Let's go ahead and set each one equal to 0. In the first one, we're just going to subtract 3 from both sides. And we get that y equals negative 3. And in the second one, we're going to add 2 to both sides. And so we end up getting y is equal to 2. what you always have to do is check your answers in the original equation. So with radicals, we can't ever have negative numbers. But if I were to plug in -3 into the square root of y plus 2, I'm going to end up with the square root of -1, which is not a real number. And so we're going to end up throwing away y equals -3 as a solution, but y equals 2 does make the entire equation work. And so the only solution we ended up getting is y equals 2.